I'm Tim Ventura, and we're joined today by Tadaya, a software engineer and data scientist with experience at Northrup Grumman, DaScient Capital, and the National Security Agency. Dawn has a BA in mathematics and philosophy from ASU and certifications in Python, machine learning, Java, and privacy from the University of Maryland, Stanford, and MIT, respectively. He joins us to discuss the applications of data science and automated analysis to highlighting trends and identifying hidden relationships in anomalous data sets. So Dawn, welcome, sir. Thank you so much for joining me. So the audience doesn't know this, but I'm going to reveal that to them that we've been working together over the last couple of weeks. You have been going through the National UFO Center reporting data just as kind of a test case, right? There's 80,000 cases of data there. And so I want to ask a little bit about your background. So I think that most professionals out there are familiar with like Microsoft Excel, PowerPoint, things like that, right? You do your charts and graphs in Excel, you drag them into PowerPoint, you mail them to all of your colleagues, and then, everybody views them on a projector, right, in a meeting. That's the traditional method. What you're doing is a little bit different. Can you tell me why you're using Python and why you're doing kind of a programmatic approach to it?
What a great question. First of all, Tim, thanks so much for having me. I know you just wanted to cut straight to the chase, but I'm so grateful. Every person that you've had on your podcast show has been way much more advanced than academically, institutionally, corporately. So I'm so honored to be here. Thank you so much. Also for your camaraderie, which has been tremendous. I haven't been disconnected to this many people, especially so in the UAP, which is exactly where we're going into. Your question was about why Python. Literally, Python it's what we use. It's what we use everywhere. We're even in a lot of the works that I'm doing with other people. Everyone's always trying to transition from old legacy coding, Fortran, C++, and translating everything to Python. Like that's just kind of the movement. Python has not just hundreds or thousands, but tens of thousands of different packages that allows you to interact with basically the World Wide Web in the most ubiquitous way that you can think of. There's such things as RESTful APIs or API management, which is an application program interface. Basically means if an internet has, let's say a database like Phoenix Sky Harbor Airport, for instance, decides to have an API on their website that includes all of the metadata, all of the radar data, everything that's happening on a daily basis, time series, timestamp, date timed, and everything. A Python programmer or an engineer or an analyst would, if they had the right resources, Python, they would easily be able to just import one package and then scrape all of that data and then just write another one line of code that says, read this as a PDF or read this as a CSV, which is a comma separated value. We're used to seeing CSVs, or as an Excel spreadsheet. And here's your data frame immediately. And you're about to see it in this notebook, how something like NUFORC, which was the database that you introduced me to, which is kind of like an archaic notebook, or I'm sorry, an archaic sort of organization web page. There just so happened to be someone who I name on here, Mr. Omariba Collins. He was the one who uploaded the NUFORC data. So whatever he did, whatever thing he did to translate archaic type web page design into a Kaggle Notebook database, that's what I am exploiting here, and that's what we're about to explore. One, you introduced me to NUFORC. Two, I use Kaggle to basically Kaggle is like an external, or basically it can run local, but you can attach it to other different GPUs or whatever to make it run stronger. But basically it's an open source really shout out a real shout out to Kaggle though, because they do allow for people who are not even new, who are just new to coding or want to do coding. Kaggle allows for them to do that. You can just easily copy and paste and press run play, pressing one button, and it'll all show for you, and you can just mess with the code yourself. That's one of the
Ah,
biggest that's one of the biggest points that I wanted to bring here too, is that although what we are studying is anomalous phenomena, um, Mr. Robert Powell, an executive director for SCU, executive board member of SCU, has already suggested that this application, this template that we've created here, is applicable to being able to address the needs of more than just UAP
yeah,
events.
absolutely. Well, and so why don't we do this? First of all, I want to break this down. The
Sure.
NUFORC data that we're looking at today, this is kind of a test case. This is about 80,000 records, and if I understand correctly, only about 60,000 of those were valid. Um,
Yeah.
Yeah,
You,
and so what you have done is you've created a Kaggle workbook that displays this as well as does trend. You're doing trend analysis on it. You're doing all sorts of detailed breakdowns, graphing. I mean, it's really quite amazing. Do you think you might be able to do a
real
screen
basic
share for us?
real basic practice. But another thing that I would like to suggest to future, let's say, data scientists or computer programmers, or whoever just really wants to dive into the notebook and create a Kaggle account and run it themselves. Actually, I don't even think you need to have an account to run it yourself. um Go ahead and I'll try to do my best to walk you through in the most simplest fashion how anyone can really do this.
Well, Dawn,
But
do you think you could do a screen share and show us? Okay, so this is the UAP Analytic Centralization Program. Again, you are working with National UFO Reporting Center data, right? There was something like 80,000 records. You weren't able to use all of those. You were able to use a lot. And one of the things that makes this really amazing is you were able to use Python to basically do trends, graphs, highlight, hidden relationships, things like that. Could you kind of walk us through it? You've got some text up here at the bar at the top. You've got like mission statement, things along those lines. Can you kind of walk us through, I guess, what you've got going on here?
Basically, this Kaggle notebook, it's a copy and paste simple template for data visualization, like you mentioned earlier, data science, visual analytics, exploring it. It's for everyone: data scientists, intelligence analysts, computer programmers, engineers, whatever, computer.
So
But
let me break in really quick. What
yeah,
is Kaggle for the uninformed, right? Because I don't know either. What is
right, yeah.
Kaggle?
Good question. Kaggle is just one. It's actually one of the only ones that I know of, but it's basically you can code in Kaggle in whatever code you want: C++, Perl, Java, HTML, JavaScript, or whatever. But Kaggle basically provides you. You see here on the side, they have home, competitions, data sets, models, code, discussion. It's basically if it's basically like a data science central. It's like we all share what we know. There's a lot of another thing that they do here is competitions, actual paid competitions. For instance, Zillow. One of the reasons why Zillow became so popular is because they hosted, like, I think it was like 150,000 or $200,000 dollar prize for who would be able to provide their Zestimate
So
algorithm.
does Kaggle actually run the code then, or does it run somewhere else?
So they use Kaggle to find those competitors. Those competitors win. As soon as they win, they take the code and Zillow buys it, right?
Ah,
So,
okay.
and that's just, I guess that's the transaction. But yeah, it's not that they run it from Kaggle, but they go ahead. They probably call the group, bring them over, and have it implemented on a wide scale, in Zillow or whoever, whatever company. There's also some Spotify data sets in here that people can explore. Spotify collaborates with Kaggle and shares data with Kaggle as well. That's another thing that I love Kaggle so much. I really want a lot of more data scientists and computer programmers and even Intel analysts to be able to start using these things, because it's one way to bridge the gap between analysts and data scientists, which is they're still butting heads in industry. So the
Okay.
Kaggle is basically one of the best ways to bridge that gap, that interaction between, that lack of interaction between analysts versus computer programmers. I'm like gonna show you guys how, anyone can, even a person who doesn't know how to run code.
Yeah. So after the welcome, it looks like the next section down there in your table of contents is you're loading your packages, right? And so basically those are just kind of what you're working with. Those are your libraries, so to speak.
Yeah. So
Yeah.
yeah, for instance, like from Python, I need to import an image, right? That's how I got this. But so although NUFORC had 80,000 data set as a CSV, I did want to do a little bit of cleaning up. But here, what's happening when you see I have these imports, these are Python packages that's already pre-made. It exists in Python repositories, and you can just pick out from them and then use them as variables, however you want to use them. They're methods or classes or whatever they are. That's what's going on here. This is me loading my files and so on.
Yeah, and so
So for
you bring the data in, and
this
then
is how I bring the data in. Right, I bring it in like right here. I basically say there's the original data set, which is the UFOs data, which is coming from NUFORC. I drop all of the nulls. That just means I'm getting rid of some of them. Some of the 80,000 data set. There were about 15 or 20,000 of them, less than that didn't have like valid longitude latitude values, for instance. So if there were any of those, I didn't want to present those because I didn't want to have any glitches in my code. So I'm dropping nulls there. And that's what this DF stands for, data frame. So I'll close that.
and
So
that's important to point out, because this goes to what Sean Kirkpatrick was talking about in terms of data, right? When you're talking about military reporting, one of the advantages of standardization in the military reporting of UFOs
yep.
is that you're able to do advanced trend analysis because you're working from a standard report. And I know one of the challenges that you ran into with this was, because this comes out of NUFORC, there are some standards, but in some of them were relatively arbitrary and they weren't always well enforced. And again, this data spans decades, right? So
there's a lot of cleaning to do as well. Sometimes the data is so big, it would take, Kaggle doesn't really run, they don't have such a great bandwidth, but they're still able to run, TensorFlow machine learning algorithms. But you want to be nice to Kaggle sometimes. So it's nice to make, for instance, like I would create a data set that would take like observations only that lasted under 100 minutes or under 60 or 100 or 60 minutes and so on, basically just creating a smaller part of those data sets. So if I wanted to run a complicated algorithm, I would probably want to use a smaller data set just for practice. But again, here there's what I sometimes I would create a random vector or a random column just to emulate or pretend like we did have the data on whether or not these NUFORC, let's just say we already had classified this event specifically as a balloon. Okay, that's a balloon. We realized that this was a sensor malfunction. That's another classification. I made these up, right? Or it was absolutely anomalous. You can create, what I created here was a column that basically randomly chooses with weights how those show up. So yes, this is cleaning up the data, creating the data, not just wrangling it, but also For instance, here you can see Powell score, because I was talking with Mr. Robert Powell. He had some ideas. He said, we actually have a way he called it veracity. He said, we have a variable veracity that we attach to these reportings, and using natural language processing, you should be able to pull what are more scientific versus what are more emotional, or soft, on the softer side. And since we want this to be a scientific approach, we want weights to be applied on that. So that's what this, for instance, this veracity column and Powell score column that you're going to see added into the data set, which does not originally exist in the NUFORC data set, but we'll see that here. So I'll just jump straight into the data set then, so that way we can, we're
Yeah.
talking
Well,
about.
and that's a difference between public data and again, military data, right? So in public data, since anyone can report, you're going to have people who are, they're overtired. It could be a variety of things. They see a light in the sky. It looks funny. They call the UFO Center and report it. Whereas with military data, it's much more standardized and rigorous. And I think because of the stigma, people are less likely to report. So there are definitely some variables that go into the kind of stuff that's reported. Again, you're working with public data here, so you're going to have to do more cleanup, and I think that's wonderful.
Yeah, a lot of cleanup, and thank goodness I'm not alone in this endeavor. There are people who are helping me clean up the data before I work with it, and saved me a lot of time. The thing is about data scientists, you ask any data scientist, how long does it take to clean up data? About 60% of the time. So yeah, so initially, like I said, we initially had 80,000 reports, but after I cleaned it out and after I dropped all of those null values that I didn't care about, we really only got down to 66,516 observations, reportings, and sightings, 15 columns, and you'll see those here. So these columns, are you able to see them all right, or should I enlarge my screen or anything?
No, it looks wonderful.
So city, state, country, shape, these are all typical NUFORC UAP related columns, variables. Comments, people who wrote reports were able to provide comments on them. I stuck with the date posted instead of the date that they said that it was, that they saw it, just because it was, again, clean, easier to parse. That was wild. Latitude, longitude, very important. I'm so glad NUFORC had the latitude, longitudes of these sightings, because that enabled me to be able to present so much more. Latitude and longitude, very, very, very useful to have, especially in an all-domain analytic effort here. I created this. Basically, I took the length of the comment, however long it was. I just wanted to know the length. I converted the duration in seconds, which was what NUFORC originally had. And I said, no, I would rather have it in minutes. So
Well, and if I could jump in again, and this comes out of a separate conversation that you and I had, but in terms of comments, right? And again, this is what the person actually reported. So, they parse out all of the stuff. The person who's taking the report puts in the lat and the long and all that. The comment is actually, I was outside, it was late night, I saw a bright star, it moved strangely, right? That's the comment. So one of the things that's, again, this is the incredible power of the tool that you're working with, is you're able to actually run those into natural language processing and pull out more data from the comments and pull trends out of what they actually said. That's, again, something you're not going to see in Microsoft Excel or more of a desktop program.
Yeah, that's true. That is true. Yeah, that Python does have the leverage to do that. That's a capability. Okay, so here are the variables, or the columns that I created, again, verified. Like I said, let's just pretend in Henderson, Nevada, there was a fireball shape that was seen. They said that it was a very strange red sphere over, well, see, that's weird because it says it's a sphere, but it was a fireball shape, right? But a lot of data cleaning involved here. But they have the latitude, longitude. Let's just say that we have a training data set or an existing data set where we have identified that that was in fact just, let's just verify it as anomalous. Let's say that this event was a sensor malfunction. Let's say this event was unidentified. That I created this randomly, but I did put weights on it in order to sort of create a more robust machine learning or AI algorithm. Veracity, again, provided to me as an idea by Robert Powell, and then we also have a Powell score, which is eventually going to be an NLP variable or an NLP derived vector that would read the rest, that would go through the rest of these columns, calculate them in an intelligible way to put an actual score into it, and that's just going to add more, not maybe validity, but more robustness to when it comes to classification or any data science applications. And I just decided to create a year month for the sake of simplicity as well. So yeah, this is what the data fork or the NUFORC data looks like, and this is what the data looks like that that I'm gonna be exploiting using here. So yeah, basic stuff, right?
Yeah,
What are the
and now I should mention that in the show notes, I'm going to put links into this so that people can actually go through this and use this. And one of the things that you have in here is you have animations, you have graphs, you have things that people can interact with that actually change. So it's important that people actually be able to see this. Kaggle is an open notebook. They don't have to log in. So I will definitely get a link. People can look in the YouTube show notes for that.
Thank you. Shout out. Yeah, shout out to Kaggle. Yeah, so what I did here was I listed just the top 20 cities. There's hundreds of cities. Top ones, of course, I only have US data because it's only NUFORC right now, but that's about to change because I'm about to be uploading more data here pretty soon. So by the way, if you are going to be following this notebook, it is being updated since it's the weekend. I work on this tirelessly. Yeah, there are more sightings in Seattle than there are in Phoenix, than there are in Las Vegas, than there are in Portland and LA, and so on. Top 20 comments. Basically here, this just provides you with the statistics on the number values, basically the number vectors, the duration in seconds. It gives you like the statistics on it, standard deviation, the quantiles, quartiles, and min and max values of them. So it just kind of gives you a little bit of an insight of like, you know, where are sightings most occurring. So that's a kind of an interesting part here. Latitude 72.7, longitude 153, right? That there, I don't know. That may be significant. I haven't checked it out. I'll look into that later, see what those sightings are.
Well, now, Don, can I ask, since you're going through these trends, you mentioned that there are, for instance, more sightings in Seattle than other areas. Did anything jump out at you? I mean, you have all of these records to look at. You've been seeing trends. Were you surprised by any trends that came out of this data?
I didn't investigate Seattle, but I was more curious about California and Florida. But I didn't look much into Seattle yet.
You also looked at shapes as well, and that's
I did.
something I think that's further down. But
Yeah.
I remember you showed that to me the other day. It looks like flying discs are on a decline in sightings, whereas
Yeah.
spheres and I believe shining lights were on an increase, right?
Increase. Yeah. We'll see that here. Really quick, this is the randomly generated verified column. So it says here that I just verified more randomly, more of them to be weighted as anomalous and less of them to be weighted as balloons. So just to give you guys an idea of how this future classifier that I'm about to show you, how that works. Yeah, I wanted to really showcase these interactive 3D plots right away, right? Here's the code for it. I mean, simple. You got the latitude, longitude, the date that it was posted. You can choose whatever color you want it to be, what size. So I took the comment length, I made that the size. So whatever size of the bubbles you'll see here represents this size. Okay, so let's jump in. I love this one. This basically I created, I used lat long as a the X value and Y value. So if you look at it just the right way, you can see that it
There we
represents.
go. USA.
There you go. Beautiful stuff. But you can fly in. You can fly yourself in here. Sorry, my computer is my computer is wild, but you can actually fly in and explore these different. Oh my goodness, sorry about that. I'm gonna upgrade, Tim. But you can explore the z-axis is actually in here. If you can't tell, it's on the right side of the screen there. Represents the date that it goes back. So the earliest it is, the more in the front it is, and the later it is, back all the way down to 1998 are sightings over here. So if you hover over them, they'll provide you basically the metadata, and I'll back up a little bit just to
Yeah, so it's actually a hypercube by time then, basically.
it is, yes, yeah, basically. One of the things that I would like to show is that you can actually click these off, um, and decide which shape, for instance, you're only interested in. So these are all of the ones that were, oh, we saw it earlier, but these are all of the ones, those were all of the ones that were, you know, recognized as fireball, for instance, right? Fireball and circle. So yeah, you can read the metadata
And
that's
one of the things that I see with your classifications also are, again, these are some of the reporting challenges in terms of the data, right? I see sphere and oval, right? I mean, a sphere, oval, and egg. Okay. And those are all very similar shapes. And
thing,
maybe it's not
right?
the same. Yeah. So, from a military perspective, they probably don't have as much work to do on cleanup because, then there's
Yeah,
this
sure.
question of, is this the same craft viewed from different perspectives, or is it just people seeing it moving or tricks of light, so there's a
Right.
lot.
There's a
Yeah.
lot. Yeah, there's a lot to uncover here, and yeah, you're right. This is only unclassified data, and yeah, I can only imagine what the military might have. But again, the point is, you know, this is a copy and paste template. If you are in the IC, please check this out and just copy and paste it. I don't care what you do with it, but I'm pretty sure you guys can find something out. That'll be fantastic.
Well,
Um,
and the exciting thing about this, again, this is what excites me about this, is we literally just said, okay, what about UFO data? Here's this database. This is one that we know of. MUFON has a database. There are also databases of many, many other things with just incredible anomalous data sets, right? That just aren't shared. They've been siloed, and not intentionally. It's just that the people who've put them together don't know what to do with them, and they're not really experts in processing the data either. So,
Right. And I think you and I are doing a rather good job, connecting with those people who need these, who are actually like really desperate for these types of analytics, right? Because they have data in forms of Excel spreadsheets and, I don't know, PDFs or old photocopies, and they have no idea what to do with them. Well, this Kaggle can provide you, a platform, basically as a platform to allow you to explore that in a visual way. And that's basically not, it's not just like my passion. It was my job for a little while, but it really, I really do have a deep affinity for writing this type of code to just put these things together
I
because
think,
I gain insight too, right? And
yeah,
uh, it shows what it provides, what we're looking for. We the AARO, the most recent AARO, uh, hearing was saying, you know, we really need to focus on the scientific approach and the analytic approach to this to provide validity to the investigation. And I think this is just one of the small contributions that will enable that will further augment that effort. Um, so this is
yeah.
California. So you can
What?
see here.
So that's California. Do you think you might be able to scroll down and show me some of the other data sets that you were able to analyze?
Oh, you wanna do these? So here's Florida. So yeah, we'll move on from that. Date posted by latitude, longitude. I thought that was really cool. You can click out the shapes and everything. So I also created a 3D of the dimensions using like shape and its verification. So just something to think about. Again, they're also sized by comment length. So I don't know that there's significance there. Um, like here we apply, I use the veracity, which will be more of like an NLP derived variable in the near future here. And we'll be able to attach that to the verification of these sightings, and that again is going to enable much more capabilities to the application of this. So okay. Oh, here's another one that's fun. Like I was talking about the Powell score. Powell score was really intended to use sort of like a deep learning method in order to identify what is weighed more, what is more important to scientific, what is more scientific, what comments in the um, uh, what comments were provided about this report, for instance, are weighed more methodically by natural language processing as being more scientific versus more emotional. And those more emotional ones are like the small, tiny ones right here. Whereas the highly scientific ones are more towards the back. They're the larger circles. So I thought that this is a really fun chart. But okay,
Yeah.
let's.
No, again, these are absolutely remarkable. That's why I'm so excited to be able to interview you about this, because what you're doing with data, and one of the things that I want the audience to keep in mind is this can be done with other anomalous data sets. It can be done with pretty much any data set. And one of the things that I've seen in the sciences is data piles up and aggregates over time. And scientists are good at analyzing it. They are, but they are also very slow, and they don't have these tools or the ability to use them available.
Yeah, right. That's right. Yeah. But here Kaggle exists and you can just Google any packages that you want if you're familiar with Python and just put things together, right? Like, so what I'm showing here is a dynamic chart. You can see that the y-axis is city. The x-axis is the duration of the observation, the colors of the shapes. They're also tagged with what country that is in, but currently I only have US, so that'll expand. But when you press play, it basically takes you all the way up from, I only took a little piece of the data, right? Just for the sake of computational efficiency. It says here that I really only just took a sample of 30,000. So we're really only looking at half of cleaned up data set from an even larger 80,000 row data set, right? So again, this is just a subset of that. So this is a way of showing what I like to call pattern of life. It's a dynamic scatter plot. You can attach other variables here based on time series, on time scale, whether it be latitude, longitude, or a particular shape that you want to put a focus on. That those are all variables that you can easily plug in yourself. And here's one that uses the entire data set. And someone that we were chatting with yesterday was like, have you thought, I was looking at here, he was like, have you thought about doing it to the larger set? And I was like, yeah, it's messy. He was like, oh, that's exactly how I imagined that it would be. So, you know, if you have the greatest computer in the world, go ahead and run this and it'll be flawless. But yes, Kaggle does have its limitations, just like everybody else's computers has limitations. But yeah, anyone else who runs this with a better computer would get better interaction with it.
Yeah. But the thing that amazes me so much about this is the NUFORC data. This is data that, again, it's been around for a long time. This is now online, graphed. I mean, people can run through this themselves and look at this and
Yes,
drill
please.
down and learn from it, right? And again, this is just the beginning in terms of anomalous data sets. So
Right. So here we're going all the way from 1998 to the ending of 2014. They're shaped um, by well, they're categorized by different shapes, different states, and so on. So yeah, I'll stop that so that way my computer doesn't.
yeah, I would imagine since it's browser based, it's probably running in JavaScript, right? It's pulling from the database and doing the processing and running it in JavaScript on the back end. That's probably why it's slow, because there's a lot of layers of processing going on there to display that.
And I'm also running on the 2013 MacBook, so that's gonna change soon. I think I'm gonna go to the Apple Store after this, actually. Okay, yeah. So that was all of the fun, dynamic 3D charts. But I really just wanted to create some basic two-dimensional charts too, just to get an idea. The cool thing is about this is you can zoom in on it, or you can just open it in a whole new different you can save it as a PNG and it'll give you the actual large size. For instance, right here. So give my computer a moment to load. Sorry about that. But we have different, oh, you know what? It's just not gonna work. But anyway, sorry. What you can see here is what I did was I did the y-axis here are the duration, and the x-axis are the different cities that these different in what cities these sightings were at. This one is also by city, but I think I colored it by it says a sample of only 500 observations. So we're really only looking at a fraction of the data. But really, kind of what I'm trying to showcase here is that even two-dimensionally, you can apply let's just say k nearest neighbors machine learning, unsupervised learning, to find out what correlations are between how long a particular shape lasted in one city, for instance. Like that's something that you can possibly explore.
Yeah, and this gives us good representative data. For instance, the vast majority of these, it looks like, are under 30-minute sightings, right? Which is no surprise, but it helps to know that. And,
Yeah.
if you were able to drill down more, you might be able to pull real trends out of that.
Yeah, we have sightings that lasted over 150 minutes. So I wanted to,
I
truncate that.
did see, yeah, I did see several of those. I wondered about that too. 150 minutes, you're talking 2 hours, right? And so,
I'm saying, I'm calling those outliers for now, right? Like I don't want to see those in my analytics right now. Let's worry about that later. Maybe it's actually significant. Like what if NLP tells me that it has highly scientific words provided? Let's say, let's say a military person provided it, right? And he knew exactly what it was talking about. I don't know. We'll find out, but I'll explore those more later. Here, what we show are um, I show the state um, on the y-axis and the duration, and those different colors that you see are the different shapes of these observations, the different shapes that people have seen. So really messy, but it tells you something nonetheless.
yeah.
Um,
Well,
here,
I should mention that you put this entire thing together in about 3 days, right?
I mean, yes,
So,
but I've been working on it for about 8 days now. I'm running on 8 days now. So yeah, and the first day was the conversation that I had with you. So really, you've been following it from the beginning. So
well, let me thank you for putting this together. I think this is an incredible test bed, and really I think that's the primary value of it, is to be able to show the power of the kind of programming that you do. That's what excites me the most about it.
I'm really excited to get more data from people because I am outreaching. I'm almost cold calling people, basically saying like, hey, can you please give me the data? NICAP has really great aviation, or NARCAP, sorry, has really great aviation UAP related reportings and sightings, but I don't see a database like NUFORC does on their website. I subscribed, so I was like, no, actually, I requested for data. So yeah, basically here, you get a really not granular, not even granular. I could have made these dots smaller and you'd be able to see more. But yeah, the majority of the data that we do have, although we have some in other countries like Canada, that we have the majority of them in US, obviously.
Yeah.
So that's gonna expand. Kevin Colby was a colleague of mine, former U.S. Air Force tech sergeant, incredible person, really drove my data science, I guess, capacity to a different level. So prior to meeting him, I was really just generating charts, and he was like, I don't get that. And then finally I started generating charts, and he was like, stop right there. I get that actually means something. You know what you're discovering here. And he really, Kevin, I trust Kevin's opinions. I don't trust a lot of people's opinions, but Kevin, he only wants to provide what's true. And I think that is really important. So I always seek his honest feedback. Very good at that. So I showed him this. He was playing basketball at the time, and he says, this is incredible, playing basketball, we'll get back to you later, have something to provide. What he did himself was he went in to the website, grabbed the CSV that I was working with, put it on his own computer, and provided us Excel analysis on using words, basically what we call the recitation of it. He basically just recites the what he finds, which I think is really important, because I don't do that. That my job is to provide the visual analytics, and thank goodness I have colleagues and partners in business that are able to really articulate what we're seeing here. But here we have, for instance, x-axis is by date. The y-axis are the different shapes, and the different colors of the dots here, the bubbles that you see here, are the different states. I don't know, maybe you can see that there's a little bit more of a situation or more events happening here with light circle sphere disk fireballs during 2004, 2006, right? It looks like there's a heavy density there. And this is only a sample of 2,000 observations that lasted under 60 minutes. So
yeah, well, and so in a moment you had, if you can scroll down, you did have the shape, and maybe this was national, it was the shape compared to the date that it was cited. You had trend lines, and that would be a little bit easier for people to identify.
yes,
There we go. That's the one I was thinking of.
This is right here what Kevin provided. Thank you so much, Kevin. Yeah, he used the same data, and he provided this. So like, yeah, let's look at what this shows.
So discs are on the decline, at least according to,
yeah, way
yeah.
on the 1951 to 2014. We do see somewhat of a rather unique increase of what is that, light? Or yeah, it's light.
Yeah, those are lights. Now, I think one of the challenges there is those could be satellites. And when you're talking about fireballs, I wonder if fireballs might be space junk burning up as well, right?
Right. Yeah. So you're saying there's a lot of yeah, that's probably why these, I don't know what's going
Yeah,
on.
I remember reading, this goes back a while, but a while ago they put the iridium satellites up, and they had these really long antennas. They would get what's called iridium flares, and people
Yeah.
were reporting those as UFO events. They say, I saw this flashing light and it did this. And what it was it was actually just the sun reflecting off this incredibly long antenna boom. So
Right. So like that could have possibly caused the spike, for instance, of 2000 or 1999 and 2012, 2013 on Fireball, right? For instance. But yeah, some really significant things to be found here, like
now,
triangle.
yeah,
There's a
and
triangle there.
triangles, that was during the run of the X-Files on
Yeah.
TV.
See,
That's
Yeah.
Another factor, right?
What's
Cultural
happening
stuff.
here is what you're doing here is you're taking empirical data and you're attaching it to basically sentiment uh,
Yeah.
information, right? And that, in a way, that's actually what Kevin. I'm not going to read all of this, but it does have some rather great insights on what he found about specific shapes. We have talked about, like what you were saying earlier. You said oval, egg, sphere. Could we just put that intelligibly somehow together to reduce or to to diminish some of the data, some of the columns from the data? But yeah, there's some very important information to be had here. But what this shows right here is kind of like what you're talking about. He was basically, this is just a random chart that he got of per capita number of cigarettes smoked per year, right? That probably has an effect, right? In 1961, gee, like you go and look up and you look at what was happening in 1961 in this area, right? And I don't know, you can compare. So that's what he was trying to do there. So
Okay.
what we could do is what you were talking about with the fireball sightings, with the iridium um, space junk that was falling into space. Go ahead and show me, provide me
Yeah.
that.
That's the, and you're talking about a classification labels, right? I think that's where the cigar thing, because people were familiar with the term cigar. They were cigar shaped. And in fact, at the time, I remember seeing newspapers where people would describe, they say, I saw a cigar shaped UFO. And so it caught on in the popular vernacular. So one of the things that might be more helpful is to break that down and say, okay, like cylinder. I think somebody mentioned that on a call the other day.
Right.
They said, just
Yeah.
call them all cylinder,
Cylinder,
and
the same almost, but or is it though? Right? Like, what, I don't know. That was one of the arguments that I was having with Kevin. Like, I don't want to do that just yet, because not all not all spheres, or not all circles can be viewed as spheres, or the other way around. Like,
it's a challenge. It's a
there's
challenge. Yeah.
a challenge, but there is a way to do it. There is a way to do it. And yeah, what this is showing, you're right. There was an increase of smoking going on during that time, so that probably explains the little spikes in cigar shapes during that. Yeah, so after Kevin's research, I did, or analysis, I basically just, these are just statistics. So this just shows you the statistics of the data set per country, the duration in seconds, the latitude, the longitude, and all of the other numerical variables. This shows you, is my Kaggle notebook not loading now?
It's loading. I think you've got just some load time delays. Again, it's running a lot of JavaScript behind the scenes. So
Let me go
folks
ahead
should
and
keep that in mind.
yeah, let me just go ahead and close some of this stuff. But right, um, there's still a lot of things to be, even just the NUFORC data itself. There's a lot to sort of be to gain from that, even just exploring NUFORC data alone. That still has a lot of way to go. And in fact, before we're even able to put more data in here, there's still a lot of things to be explored inside NUFORC. We can
Yeah.
still pull some things here. Yeah. So
Well,
this is definitely.
Dawn, on that note, we should probably close things down for today. But let me thank you so much for your time. And let me close by asking, what do you expect to come next in the next, as this progresses, as you continue working on this data?
Well, there, as people can scroll down more, there are applications of machine learning techniques here, where I basically create a template for using NUFORC data, for being able to basically detect whether or not, or verify whether or not it was a balloon, and so on. So the the goal of my notebook here really is to show that we can in fact use empirical data to provide research and investigate, and not just that, but also use data science to you know, to make better predictions, or to just provide more insight and more intelligence on these empirical data that we can get, right? So for here, for instance, really quick before we go, I just wanted to show you guys really quick, sorry, but I created a machine learning use case where I said, hey, this one was verified as unidentified. I encode the whole data set. I trick the computer by taking it out, by taking that particular column, the verified column, out. I run a prediction. I run a prediction called the multi-layer perception classifier, and it was able to predict what that target variable was without knowing, by just using training data. So I guess in conclusion, what do I want out of this, or what's going to happen after this? It's all finally starting to ramp up. This is a natural disruption to our modern comprehension of philosophy entirely. So we are going to be writing. I'm already in the process, or in the works of putting together projects, and we'll be putting up a research publication pretty soon about all of this and what we find. I wanted to, I want this to be shown to everybody. I want anyone who cares about UAP and even just preserving national security interests to explore this, because I do have notes and clickable links here that people can explore and just do for themselves for fun and contribute. The title of this project was to a lot of my mentors, and there's people here. If you have ideas, email them to me, and I'm most likely going to put them in here. This is a collaborative effort. I don't intend on doing this by myself, or even presenting it by myself. The more people I believe I have partnering with me, connecting with me, just sending me anonymous data. I don't care who you are, right? If you want to see that on here, send it to me, and I'll play around with it for absolute fun. And like what you see here, the incorporation of ChatGPT, that's going to happen, and I already have some people helping me with that. This is a rundown of the actual duties that's given as responsibilities to the AARO from Congress. And some of the things that I highlighted here are one of the things that we're working on, developing processes and procedures to ensure the incidence of these, and creating a centralized repository. We are on the works for that. We are establishing the procedures to require timely, consistent reporting of such incidents, right? We have not just historical data, but we have data coming in. And yes, this is all unclassified purely. I put X's on the ones that I believe I've already addressed. Related phenomena events occurred during a 1-year period or during a historical period. Analysis of data, right? But there's also other applications of concern here. For instance, letter L, an assessment of any health-related effects, because there have been reports from in the public saying that people would experience some physiological or psychological or any sort of health related consequence from interacting with these anomalous phenomena.
Wonderful.
But anyway, yeah, it's an ongoing project. I try to put as much information on there as possible. Again, my computer is slow, but your computers will make it run so much faster. So please explore it as much as you possibly can. Thank you guys so much. Thank you, Tim, for for putting
Absolutely.
all.
Well, and Don, thank you for putting this together. Thank you for your service, both in the government as well as your continuing service with Northrop Grumman. So
thank you so much, Tim. Thank you so much for having me. Yeah, I really couldn't have gone this far. I do want to say that. You're so humble, but yes, thank you for bringing me on board. I feel so honored. Thank you. I'm very grateful for that. And yeah, we're obviously talking all the time. So let's continue working on this, and I look forward to how far we can go, because I do believe we can get a lot done in our lifetimes here.
Absolutely. Thank you again, sir.
Yeah, thank you. Thanks, Tim.